Hey, welcome to part 9 of the section about parabolas. Let's do one final example and then that should be the end of this section. Okay, so the example I guess we can do, let's take y equals x squared plus 3x plus 2. You know what, actually this isn't a very good example because we already know how to do it. It's actually very easy. All you have to do is factorize it. We can see quite clearly that this can be factorized as x plus 2 times x plus 1. And hence we already know how to draw it real easy. It's real quick from the section before. We know that it goes through x equals -1 and x equals -2. Turning point will be -1.5. And so our graph is going to look something like this, where the y value of the turning point can be located by putting -1.5 into the function right here, which is y of x. Okay, so this isn't actually a very good example. Let's instead do one that's a bit harder. Let's do the following. Let's say y equals -2 x squared plus 3x plus 1. And maybe this one can be factorized as well. I don't know. I can't do it off the top of my head. So let's just suppose that it's too hard to factorize it for now. And so what we're going to have to do in order to find the turning point of this parabola, remember when we're drawing them, we should know where the turning points are. We're going to have to complete the square on this thing. So let's go ahead and do that real quick. So first of all, let's factor out -2 from the first two terms. So we get -2x squared minus 3 over 2x plus 1. And we'll double check that everything works out the way it should. We got -2 times x squared is -2x squared, good. And then -2 times -3 over 2x. Well, these two negatives cancel out and we get positive 3x. So that's exactly what we wanted. Okay, good. So we haven't messed it up so far. Okay, and now for the actual completing the square part, what we observe is that if we take this number here, -3 over 2, if we divide that by 2 and then square it and then add it on and then subtract it, we're going to get something that we can factorize. We're going to get something that we can factorize. Remember, if we've got like x plus b, I'll use a different color, use yellow. If we've got x plus b squared, this is going to be x squared plus 2bx plus b squared. Well, that's why we're dividing the middle term by 2 here and then squaring that, because our -3 over 2 is actually 2b in this example. So that's what's going on here. Let me get rid of this actually because I want to get rid of that red circle. All right, good. Okay, so -3 over 2 divided by 2 is -3 over 4. And then when we square that, -3 over 4 squared, that's going to be positive 9 over 16. So this is equal to -2 times x squared minus 3 over 2x plus 9 over 16. And then we want to minus 9. Oops. We want to minus 9 over 16 again. Otherwise, this part and this part are no longer going to be equal if we don't minus something that we just added on. Okay, so here's where we're at so far. Everything is still the same. All we did is add on 9 over 16 and then subtract it again. So we haven't changed anything. Still got to put on the plus 1, of course. And now we observe that, yay, this thing is a perfect square, as it should be. Because this is equal to -2 times x minus 3 over 4 squared minus 9 over 16. plus 1. Let's double check. X times x is x squared, and then 2 times negative 3 over 4 times x. Well, negative 3 over 4 times 2 is negative 3 over 2, so that is indeed negative 3 over 2x. And then finally, negative 3 over 4 squared is indeed 9 over 16 as we calculated. So, yes, this part is the same as this part, and this part is the same as this part. So, we still haven't messed anything up, we're still good. And so finally, one last step. Let's expand this bracket out. We get negative 2 times x minus 3 over 4 squared minus 9 over 16 times negative 2. Well, plus negative 2 times negative 9 over 16. I guess there's another way to say that. So that is going to be plus, because remember the two negatives will cancel each other out. We're multiplying a negative by a negative, that's a positive. So it's going to be negative 2 times negative 9 over 16, which is, of course, 9 over 8. So plus 9 over 8 plus 1. And so finally, 9 over 8 plus 1 is 2 and 1/8. Because 9 over 8 is actually 1 and 1/8. And then we add 1, we get 2 and 1/8. Okay, let me write this down real fast before I forget it. Negative 2 times x minus 3 over 4 squared plus 2 and 1 over 8. Okay, so next section, let's actually draw this thing. So negative 2 times x minus 3 over 4 squared plus 2 and 1 over 8. It's our job to then go ahead and actually draw this graph. So here's our y-axis, here's our x-axis. Okay, so where do we start? Well, something to observe. This negative, that negative right there, that means our graph is going to be upside down. That means our parabola is going to have this kind of shape, because all the y values will be negative when they're usually positive, and all negative y values will be positive when they're usually negative. So that's the first thing to notice. The second thing to notice, where is our turning point? Where is our turning point? Well, our turning point has to be when x is equal to 3 over 4, because if I put 3 over 4 in there, I'm going to have negative 2 times 3 over 4 minus 3 over 4 squared. So it's going to be negative 2 times 0 squared. So that whole thing would cancel out to 0. And so the biggest number that our parabola can possibly be is 2 and 1/8. That's the highest y value it can reach, and therefore that's the turning point. Notice that because of this squared term, the smallest number this part can actually be is 0, because when you square something, it's always bigger than or equal to 0. And since we're timesing it by negative 2, the bigger this part is, the smaller this whole section is, and hence the whole thing is going to be less than or equal to 2 and 1/8. Anyway, enough rambling. So our parabola has the turning point x equals 3 over 4 and when x is equal to 3 over 4, we have y, I forgot to write y equals negative 2 times 0 plus 2 and 1/8. So y must be 2 and 1/8. So here's 1, by the way. And here's 1, here's 2, and then that is 2 and 1/8. 1/8. Hopefully you can read that. So our parabola's turning point is right there when x equals 3 over 4 and y equals 2 and 1/8. Okay, well, you can plot some other points now. Maybe it's good to find the y-intercept. And the y-intercept is going to be when x is equal to 0. So when x equals 0, we're going to have negative 2. Let's write this down. So y of 0, the y-intercept, is going to be equal to negative 2 times 0 minus 3 over 4 squared. So negative 3 over 4 squared, that's the same as 3 over 4 squared. 3 over 4 squared is 9 over 16, plus 2 and 1/8. 2 and 1/8. So, well, negative 2 times 9 over 16, that's negative 9 over 8, or negative 1 and 1/8. Plus 2 and 1/8. And so 2 and 1/8 minus 1 and 1/8 has got to be just 1. So our y-intercept is 1. And I mean, you can plot more points if you want. You could plot, I guess, 1.5, and you would find that by the symmetry, because this here is the same distance as this here. They're both 3/4. So by the symmetry, y of 1.5 should also be 1. And so we know our parabola goes through that point. And you can plot a few other points if you want to. You'd probably find one there and one there. And yeah, that's how you draw your graph. Doesn't have to be amazingly accurate. Oops, better be more accurate than that though. Doesn't have to be amazingly accurate. The whole point is so that the examiner knows you have a pretty good idea of what the parabola looks like. Okay, I guess that's it for parabolas. Thank you very much for watching. Don't forget to check out the notes and do the exercises at the end of the section. And see you guys next time. Thanks very much. Take care. Bye.